property. I'll use this video tutorial to talk about the phasor concept. Okay, and maybe I can explain a little bit about the animation. I put it on the APSC246. Okay, to understand the phasor concept, first of all, we need to know what the Euler's formula is. Right? So the Euler's formula says e to the power of j theta equals to cosine theta plus j sine theta. Okay, so I'll use one of our assignments as an example here. So the assignments here is 40 sine 50t plus 30 cosine 50t minus 45 degree. Okay, in order to use the phasor to simplify addition of two sinusoidal function, we have to make sure two things. Number one, both of them, okay, they have to be either both cosine or both sine. But here one is sine, one is cosine, so we have to change it. And the other thing is we have to make sure that these two functions are having the same frequencies. Okay, if these two frequencies are not the same, basically you won't be able to rewrite these two functions into one function, right? So because they have the two functions same frequency, we'll be able to rewrite this guy here into one sinusoidal function. Okay, one sinusoidal like this. Okay, if there are different frequencies, then you won't be able to have this. Okay. So number one step, we rewrite the sine function, okay, into this cosine. But you have to minus 90 degree to keep it the same. Okay, so here's what we get. Okay, so essentially cosine theta minus 90 degree equal to sine theta. Okay, so what do we do next? And I don't want to operate or manipulate this whole thing in the real domain, right? This is a real domain, and I want to operate in complex domain. Now, in order to do it in the complex domain, so I have to convert it into complex. So this real domain, right? So the first term here, right, is just a real part, okay, of 40 ej 50t minus 90 degree. Okay, and second term is 30 ej 50t minus 45 degree. Okay, now you may wonder where this is from. Okay, let's rewrite it again. Okay, so this cosine 50t minus 90 degree, okay, right, is what? If I wanted to equal to, well, it comes from a complex number, right? Complex number, if this is a real part and this is this imaginary part, okay, so this cosine, right, if I take the real part out, that's give me the cosine 50t minus 90 degree. And what's inside this big bracket according to my Euler's formula? And that's basically ej 50t minus 90 degree, right? So the theta here is this 50t minus 90 degree, right? So this is where how I got this equation right here. Okay, I got this equation. Okay, so let's move down a little bit here. Okay, so now my v of t, okay, my v of t here is, can take out this ej50t, which is the common part, and leave out this one here. Okay, leave out this there, right? Okay, so what do I do next then? Right, what do I do next? I don't want to do anything with this one here, so I want to basically simplify this whole portion at here. Okay, so essentially, actually, this is called the phasor. Okay, this is the phasor for this function, okay, or here, and this is another phasor. Okay, this is another phasor. There are two phasors basically, and addition of two phasors. Okay, so let's see what this addition of the two phasors, ej minus 90 degree plus 30 ej minus 45 degree. Right, now it's time to use the Euler's formula again. So the first term is cosine negative 90 plus j sine negative 90 and 30 cosine negative 45 j sine negative 45 degree. Okay, so it doesn't look like this. Let's go down here. Okay, well, I guess you can definitely calculate the numbers. Okay, once you calculate, and you end up with 21.21 minus G 61.21. Okay, so I got a complex number. Okay, but what I have here is a exponential thing, so I want to express this, okay, into a polar form, basically. Okay, so apparently R is square root of a squared plus b squared, okay, which is of course 21.21 squared plus 61.21 squared. Okay, and I give you 64.78 roughly. Okay, and phi equals to tan inverse b over a. So b is 61.21, a is 21.21. Okay, now this is where in the class I said you have to look at the actual location here, the actual location of this complex number to determine the value of phi. So where is the a? A is positive, so 21.21, and b is negative. B is negative 61.21. So the phi angle here is a negative number. So negative angle, which equals to negative 70.9 degree. Okay, so that's roughly that. So now we got theta, we got r, and we can basically this is the addition of the two phasors. Okay, and we can move back over here. Okay, so my v of t is the real part. Okay, ej50t. Right, r is 64.78. Okay, phi is ej phi negative 70.9 degree. Okay, yeah. So group this whole thing there, and you will get 64.78 and cosine 50t minus 79 degree. There. So now we made use of the phasor and simplified the original function here. Okay. Yeah. Now, if you recall that I do have an animation on the WebCT there, and so let me show you this. Okay, let me show you this. Let's give you a meaning of the phasor additions and what exactly does it mean. Okay, now let's take a look at the first one here. Okay, take a look at the first one. So what I have, the first function is here, cosine. Okay, so cosine 50t minus 90, right? Okay, let's take a look at each one of them. Okay. Okay. So cosine 50t minus 90, and we said it's the real part. EJ 50t minus 90. Okay, and of course there's a 40 here. Okay, which is 40. Okay, real part. Okay, EJ 50t and EJ negative 90. Okay, negative 90. Okay. Okay, so if you can put a 40 into it, and that's fine. Okay, yeah. So let me graph this one here. That's the second to the other one. Let's write the other one. 50t minus 45 degree. This is 40. This is 30. 30 here. Okay, so that's the real part. Let's see, 30 EJ 50t EJ negative 90 here. Okay, or one more here, EJ 50t 30 EJ. So then let's start 45 here. Why it doesn't work? So anyway, it's 45 degree, negative 45 degree. Okay, so I'm going to graph this thing on the complex plane. Okay, so this phasor is 40 here. Let's move the 40 over here into it. Okay, so this phasor and this phasor. Let's take a look at the first phasor. Okay, so the first phasor is 40, e.g. negative 90. 40 means the r is 40, so I should have a circle. Okay, let's see, the circle will have a radius of r as 40. Okay, now where's 90 degree? Negative 90 degree is here, right? Negative 90 degree is here. Okay, so basically this is your negative 90 degree here, right? Okay, and this is where your phasor, this is basically this point here represented 40, e.g. negative 90 degree. Okay, and the second point is 30, e.g. negative 45 degree. So negative 45 degree is here, right? It's here, negative 45 degree. Okay, but it's a 30 degree. Okay, well, I guess my drawing is not too good, so I need to draw another circle here with a radius of r equal to 30. Okay, so the second one here is up to here, actually. Yeah, up to here. So let's see if I can erase this portion. Okay, that's good. So I can erase this portion here. Okay, make it clean a little bit. Okay, so there you go. Okay. Okay, so I have a point here, and that is the second one here, 30 e.g. 45 degree. Okay, and we are adding the two phasor together. So you're like adding the two vectors. Imagine there's a vector here, there's a vector here. So you're like adding the two vector together. And once you add these two vectors together, okay, let's now get rid of these two, get rid of the writing here. Okay, and when you add the two vector, and where's the new vector? The new vector using the parallelogram. Right, using the parallelogram, the new vector is here. Right, the new vector is here. And what's this new vector? And that is basically what you get at the top over there for the phasor, right? For the phasor here, this one, right? That's what you're gonna get. Okay. So this is 64.8 e.g. negative 70.9 degree. That's the new vector here. Okay, and it's on a circle. It's on a circle which is r equal to 64.8. Okay, so that's basically addition of the phasor. Then what do you do next? Then you look at this one here, right? So what do you do next is all of them, right, has the same frequency of 50t. Same frequency 50t. So then when t equal to 0, okay, they are at this first location here. Now imagine once t here, right, or t, this guy here, started to change, okay, then the vectors, okay, these vectors will start to rotate, okay, and the direction rotation here is counterclockwise, okay, counterclockwise rotation, okay, like rotation in this way. Okay, so essentially this is what I give you on the WebCT here. Okay, you see the red line and the yellow line are the phasors of the given two functions, and the purple line in the middle is the addition of two phasor. Okay, and once it started to rotate, right, they all rotate all together, right, as the time t is varying. As the t is varying, it's rotating in it counterclockwise. Okay, and starting position is the starting position is what I give it to you over there, over here. The starting. This is our starting position, right? Starting position. Okay. Now, what about what's this graph show here? You know, what's the projection of this guy on a real axis? You see, there's a vertical line, basically the projection of each one of the vectors on the horizontal axis.